Hello friends, this is Rupesh and you are watching CPP Nuts video series on array interview question series, and this is question number 12. Find intersection of two unsorted arrays. So question number 11 was find intersection between two sorted arrays, okay? Because if your array is sorted, you can take the advantage of sorted data and come up with a better solution without using any extra space. Actually, you can solve this with a good complexity. But if your data is not sorted, then what would be the trade-off and how can you achieve a good time complexity over compromising a little bit of space complexity? We'll see that. So if your array 1 is like this and your array 2 is like this, then we can see that they are not sorted, and you want to see the intersection, meaning the common elements in both the arrays. So see, how would you do that? I mean, what is the basic approach you will use if it is on paper? Like, you will see this guy is available here. Yeah, it is available. So you'll say, okay, 5 is there. Then you will search for 3. So how would you search? I mean, your eyes will start from here and it will go till the end, right? And that's how you did for 5 also. You wanted to find this 5. I mean, you can choose anything. Like, you can search this 1 inside this array, or you can search 5 inside this array. No problem. It will always be n cross m or m cross n. So it doesn't really matter what you choose. So let's suppose you are choosing this array and searching these elements in this array. You found 5 and then you are going for 3. So your eyes will start from here and then you search, okay, you found it 3. So 3 is also there. 2. You will again start searching from here only, right? Then you will see, okay, 2 is there. Then 2 is also common. 10. You'll start and search till the end. So do you see a pattern here? For every single element in this, you are actually searching this whole array. So basically we are paying this n cross m. Basically it is n square. And you know that in interviews, if you come up with this solution, they are always going to push you. Can we do something better? And answer is almost always yes, it is. So let's see how we'll do that. So anything coming in your mind, like what can we do just to avoid this n cross m? You just want to avoid searching for this element in the entire array and then this element in the entire array. You want to optimize this part only. Like, you don't want to search the entire array. You wish you could have just taken this element and asked this array, do you have this? And this array could have just taken one comparison, or let's say constant comparison, to give you the answer. It is not going again and again for n time. And we know the best solution for that is unordered set, because this guy uses hashing, which can result your search in order of 1 in average cases. Yeah, it can go wrong, I mean, in the worst case, but this is the average case and you can rely on this. Or at least if you tell the interviewer, they would be really happy to see this answer coming. So how will do that? Actually, your data is in array form. That's why you have to search again and again the entire array. Is it possible that you push this data into some unordered set? Okay, now this whole thing is initialized into unordered set. So we have set here, right? This is set, meaning there won't be any duplicacy. Like if you have again 1 here, 1 comma 1 comma 5 comma 5 or something like that, or maybe 5 here also. So we have 3 5, right? But then after inserting these things into this set, you will have only 1 5 in this and 1 1, because it is set. Unordered meaning it is not going to store all these elements in any particular order. They can be stored in any way. They won't be sorted in ascending or descending order. So basically there is no order. That's why it can give you in order of 1 complexity for searching and insertions. And if it is set, not unordered set, I mean only set, then in that case it uses a balanced binary search, and that is like a costly operation. We have log n in there. Okay, so we'll use this balanced binary search when we need an ordering here. Okay, but interviewer is not asking you to take the intersection and result in a sorted way, right? If they are asking, go for it. I mean, you have to go for this balanced binary search or set, not the unordered set. As long as they are not asking for order, you go for unordered set. So we have inserted everything in our unordered set. Now how do you go about? Now it's very easy. As you have this array 2 inside this unordered set, what you have to do, you just loop over this guy, array 1, and ask array 1's first element, is this available in this? If it is available, then it is there. So you just make this entry. So 5 is available, and we can find that in a single or a constant search time. And similarly, you'll do for 3, 2, 10, 11, and 12, and you will have your result. Okay. Now what is the complexity? You created this arrays unordered set. So that basically took, if this is like M size, then that took M, because you have to traverse on each and every number here. Okay. And insertion is order of 1 or constant. So I'll just consider that, okay, that is the best way. So I'll still consider this as a order of M. And then you are iterating over this guy, right? And for each and every element, you are searching inside this. Not this, this. Okay. So that is also order of N multiplied by order of 1, which is constant. And here also it is like multiplied by order of 1, which is constant. So instead of 1, I can say C. So we can still assume that there is some constant time taken for searching and populating the data. But as these things are like constant, you can ignore them. And still the final complexity is going to be order of M plus order of N, which is like order of M plus N. Okay. So this is really a good complexity. Time complexity. And the space complexity is like, you see that you have this unordered set, extra space you got for you, and that's the penalty. So if you want a speed lookup, you have to pay this penalty. If you don't have much space in your device and stuff like that, then you go for one by one searching, and you just pay hefty price if you have a very big array. So it's up to you, as all these data structures are highly dependent on the application you will use, but let's not go there. So I think we're done here. Thanks for watching, guys. Bye bye, take care. I'll see you in the next videos, and don't forget to hit the like button if you like the video. Bye bye, take care.